Hello, everyone. Welcome to PyData Global 2021. My name is Hoda Rezaei. I'm your chair for your session. Feel free to kind of rename you in this session. Hope everybody's comfortable, and I'm looking forward to this session. The first session we have in this block is with, I hope I said that correctly, Hoda Rezaei, Energy Solution Lead at Integra Data and Analytics Solution, and she'll be talking about innovating in the oil and gas industry with AI and ML. Hoda is a strategic thinker focused on adding value to the oil and gas industry. She has a passion for data and analytics with a great understanding for business processes, pain points, and constraints. In collaboration with her data science team, she has delivered many successful projects. So I'm very excited to welcome you today. Hoda has asked that questions shall wait till the finish. So without further ado, over to you.
Thanks for the introduction, Florian. I'm just going to start sharing my screen. I'm really excited to be here and present to you innovating in the oil and gas with AI and machine learning. This has been a really exciting journey since I started in the oil and gas with an engineering background and transitioned into data science. And now I'm just happy to share whatever we found out during this journey with our community in open source and oil and gas. Just a little bit of agenda of today's talk. I'm going to do a really quick introduction, and then we move on to AI and ML adoption in the oil and gas industry. And after that, I will be sharing with you some of the use cases that we have done, some of the outcomes, and then I leave the floor open to discussions and questions. So at Integra, we are a group of engineers and computer scientists. Our focus and main goal is to equip enterprises and individuals with the most advanced technologies and methodologies so they're able to solve their real-world operational challenges in the oil and gas industry. We recently were acquired by a data analytics software and service company called now Vertical, which the mission is to help the clients win in the digital economy. Now let's move on to the analytics gap in the oil and gas industry. These main roadblocks that we see in developing analytics solution in oil and gas industry slow down the AI ML adoption, project success, and ROI in the organizations. One of the main roadblocks is data. Data is scattered and siloed across many applications. It is usually processed manually, which increases the risk of contamination and human error. Working with the data in a manual process is consuming the productive time of engineers. Data is underutilized and rarely translated into actionable insights. Processes in the oil and gas industry, they don't scale to current industry needs, are highly manual and inefficient, and are not repeatable and not designed for analytics, which brings us to the next roadblock, which is analytics itself. It's what we call analytics today is more metric-driven as opposed to insight-driven. There are many dashboards, many graphs that is created, but limited insight is generated out of those. And these insights are not integrated into business processes. When it comes to technology, existing technology is very complex in the form of legacy softwares. They're very costly and very hard to implement, and the licensing model usually makes it very hard to scale to the whole organization. They lack flexibility when it comes to the innovation and are not designed to fit into different skills and expertise levels. It's very hard to think out of the box when we're using these legacy softwares. But how Integra is actually filling these gaps and how we have learned to tackle some of these roadblocks and these challenges. And Integra would believe in a collaborative methodology in delivering repeatable AI ML solutions across a broad range of use cases. This end-to-end methodology brings a different dimension in decision-making. This will take data-driven decision-making to a completely different level where the right data is used and utilized to generate insights and make an impact into the way that everyday work is done. Well, the impact of this methodology is reduced costs, reduced risk, proven return on investment, improved safety, and reducing the environmental impact, which is very important nowadays. Now, how do we align the business and the analytics project? So we need to find the main pain points, and just a few examples we have here are in the areas of predictive maintenance, pipeline integrity, health and safety, process optimization, and production optimization. And we try to solve these pain points with the analytics. When it comes to analytics, data is everything. We want to maintain a single source of the truth across the application for the entire end-to-end solution. We should limit the data movement through applications, through users, so we eliminate the risk of contamination, which is a very huge risk when it comes to the data. We need to prepare the data to be able to use it for analytics. And these data comes in different formats, it comes in different frequencies, and it has to be integrated and properly engineered for delivering a successful data science project. We want these solutions to be repeatable. We want them we want to be able to scale them. We want everyone across the organization to be able to use this solution. And as part of our commitment to data science and oil and gas community, we have developed some of the common solutions for the oil and gas industry in the form of these repeatable notebook templates, which we have on our platform, Digital Hub, which I'm going to talk about it, and the technology. We have developed a data science platform using open source components, which hosts many applications for data science and business intelligence and these repeatable workflows. Using open source will eliminate the cost of licensing and inability to scale. Leveraging our platform, we put the highest grade applications, security, and computation in the hands of enterprises across the industry. And with Digital Hub self-service capabilities, we are actually bridging the gap between IT and business. And with that, I'm going to kind of talk about some of the use cases that we have developed for the midstream and upstream oil and gas. These are just examples of what could be done. What is the art of possible when it comes to analytics applications in the oil and gas industry, and what are the outcomes? I'm going to deep dive in one of these use cases just to show you how we approach the problem, how we identify the pain points, and what are the outcomes of an innovative solution in the industry. So this pipeline failure simulation is an innovative approach to forecasting pipeline failure. It is very critical to identify the defects and identify the main problematic areas in the pipeline early enough. So pipeline engineers are able to make the repair and big decisions for these defects in a timely manner. POE is the most critical factor for these integrity decision making. It's the probability that the corrosion defect detected and sized by an inline inspection tool exceeds the industry criteria and leads to a failure. Now, this POE has been traditionally calculated using a deterministic statistical method, and that's how, in this approach, they use the average of these measurements and these variations. They don't take into account the uncertainties in the measurements when it comes to the ILI and the errors in the reporting of the inline inspection and the variations in the pipeline specifications. Growth models across the pipelines are different based on the environment, based on the type of product that is moving through the pipeline, based on the size of the pipeline. But what has been used traditionally is a really generic corrosion and linear corrosion model, which does not reflect the reality of the growth of these corrosion defects in the pipeline. It is not computationally optimized for large ILI files. It gets very costly and very complicated if you want to run this solution for the entire pipeline with many features, and it's hard to scale. There are many pipelines out there with many features, and if you want to kind of scale this solution to this entire system, it would get very complicated and sometimes it's impossible. But having this accurate POE is very important to reduce the chance of pipeline incidents, eliminate the unnecessary repairs, and go and actually pay attention to the sections of the pipeline that are more problematic and need immediate attention. So having an accurate POE will bring visibility to integrity engineers, and so they can make these integrity decisions, which are very expensive decisions, backed by data and analytics. Now, what Integra has done is we leverage the Monte Carlo Markov chain simulation model to generate a POE distribution based on all these variations in the pipeline, in the measurement tools, and in the environment of the pipeline. And we bring all of them together in forms of the distribution and feed it to the Monte Carlo Markov chain model. So we're able to generate a scenario for POE. And with generating millions of simulation, we're actually able to have a better understanding of what is the most possible POE ranges for the specific defect. So we leverage cloud computing for scalability, and for a large amount of POE simulation, we can just easily run this, and it can be run within for the entire pipeline system. Just an example, in less than 6 hours, we ran the simulation for 300 corrosion defects and 10 million simulation, 10 years forecast. Here you can see some of the graphs that I just put here, so you can see the outcomes. Here on the left, you see the POE distribution for one defect and one feature. So you can see that how it's distributed across a range. And when you're making the decision, you have a range in mind that what POE could possibly be. And then the depth of the defect, which is very important factor in making the repair decisions, also is presented here in form of a distribution. And these graphs on the right, they show the 10-year forecast. So for a particular feature, how this feature is going to grow, and how much of the metal is going to be lost during this 10 years. So, and this is the probability of accident for these features based on their size and based on their location on the pipeline. And this is so clear that you can see, okay, when they're going to exceed the threshold and the criteria that we have set for them. So, you know, for example, here you have 5 years or 4 years to do the repair, and then you can plan your integrity activities based on that. Now, throughout these years and throughout this journey, we've learned so much. We have come to these points that can set us up for success when it comes to delivering data science projects in industry. And these are not specific to oil and gas; they can be applied to any industry. First thing first is you need to have a clear understanding of the problem that you're trying to solve. What is it? Is it a time failure problem you're solving? Is it a energy management problem? Is it a pipeline integrity? So you have to have a clear understanding of the problem, and then you have to have the business outcomes in mind. Okay, how is it going to impact the business? Is it going to reduce my risk? Is it going to reduce my costs? And then you have to set your goals. Goals should be reachable and address the largest economic opportunities that fit your organization infrastructure, data, people, and process capacities. Then you have to have access to the right data and technology. So pick the right size of data, pick the right frequency of data. If your pump or your event is happening every 3 months, you don't need to look at 3 years of data. That just makes the process complicated, and your time to value and your time to generate the insight longer. You need to use the existing technologies. Don't waste time and resources on building complicated technical solutions or tackle too much data, which requires a lot of like infrastructure and computation to deliver the solution. You have to be able to pivot quickly. You have to be flexible to redirect your project. If you see something is not working or it's not a problem, and you need to be able to pivot to a adjacent problem or from upstream or downstream, just to be able to show the results. And these analytics and data initiatives must yield results almost immediately and continuously in order to create the necessary momentum and support across organizations. I usually say a need for a speed approach can help you move to action really quickly and get the support that you need from the organization. Well, and then it brings us to the failing part. Don't be afraid to fail early, right? You might find out that this is not a solution, it's not feasible, and this is not the problem that I want to focus on. And that's very good to happen in earlier stages of the problem before you actually dedicate a lot of time and resources to a problem that is not worth solving. Be agile. It's very important that you implement the solutions using agile methodologies. Well, avoid filing for waterfall methodologies. It's best to use iterative approaches and deliver values incrementally and in stages. Through these agile methodologies, you develop a business case and create a roadmap for implementing the insights, and then adopt this strategy based on your business needs and capacity. So it's very important to be agile and start small. Break down, if you come across a really big problem, break it down into smaller pieces and tackle them one by one. For example, start with one pump. If you want to do the predictive maintenance on your pump, start with one pump, solve it for that one, and then you can scale it to the entire pump station. But when you have the insights, you can build on it and you can bring in more data and more factors into your decision making. One of the most important lessons that we've learned is that we need to have the support of subject matter experts. They are the ones who are actually dealing with these problems, and every day they come across these challenges and they have to solve them. And they entirely know the process, they know the technical stuff, they know the business, and it's very important to onboard them and validate the insights with them. It's just good to have frequent touch points with them, so they are on board, and our model also should be simple so they understand it clearly. And then the ones that were actually going to use your solution and take that insight and turn it into action are the end users. Once you generate your insights, at the beginning, you're only dealing with the front line of the business, the operators, someone who's actually doing the work. And they have to be on board. They have to be engaged continuously to make this project successful. And they have to be able to adapt to the change. They have to have time, and they have to have proper information and structure to adapt to this change, because it's going to change their everyday work. And then the outcomes, which is very important. We have to have the business value in mind in every step of these projects that we deliver. What are we going to achieve in the end? Is it reducing costs? Is it improving experience? Is it reducing risk? Is it increasing the throughput and the production? So with having a clear outcome and a business value driven project, you can have the business decision makers and the end users on board with you. That makes your project successful. So I think this is it from my side. Florian, I hand it up to you for any questions.
Excellent. Thank you so much. That was a great talk. We have already a few questions in here. So I don't know, you can check as well the Q&A, but other than that, I'll start off with Srinivas from Houston. He's asking for the corrosion defects within pipelines. There are several factors that influence corrosion, like flow medium, pipeline material, contaminants, etc. How did you generalize this to predict failure?
So we actually use the variables that we have in hand, and then this is a good point, and this is a good question that you asked. How I'm gonna answer this is, so we actually defined models and distribution for each of the input variables. So when it comes to this, the Monte Carlo Markov chain simulation, we had to deal with two different variables. One of them were constant variables, and the other one, the ones that had a distribution. So we, based on the data that we had, right, we picked the distribution for any of those variables that we were able to. For example, we picked distribution for the depth of the defect. We picked distribution for the MAOP, which is the maximum operating pressure in the pipeline. But some of them were constant. So some of these variables that we had to input to the simulation had a constant value that we weren't able to find a distribution for them. But what is good about this simulation is that it's flexible when it comes to the inputs. So if you have in your data in your organization, right, you have access to the distribution of any of these variables, you can easily adjust the model and have the input as a distribution. So you're taking into account that variations and those differences in the measurement. But you need to work with whatever you have, right? If you don't have the distribution, you just feed the model the constant value.
Excellent, thank you. I hope this answers your questions, Srinivas. I'm gonna allow Raghu to talk, so maybe you can ask your question yourself. Otherwise, I'm happy to also.
Hi, this is Raghu here. I'm from a traditional engineering firm too, where we need a lot of convincing to be done for the effort to show the benefit of data science and data analytics to executive and management. So I was just curious, like, how did you overcome the communication barriers in a traditional engineering or like old school mindset kind of workplace?
Well, that's a very good question, and I believe this is the most challenging part when it comes to start a data science project or an initiative in the oil and gas industry. There are many ways. It depends who you are actually talking to, right? If you're talking with the IT team, it's different how you approach it and how you position your project as opposed to when you're talking to the technical team. Because these groups, they have their own concerns and they have their own strategies, and all of them are valid. So you need to be able to propose something that is going to help them within what they're doing every day without interrupting any of their services and without causing any more pains as opposed to like the improvements, right? And that's what I have usually found out is that it's very easier when you go and present to them something that has already been done. So if you want to solve a problem, you need to go and find examples that other people have done it. That tremendously helps just to inform them and kind of bring that thought leadership into the organization, just to show them examples of, okay, yeah, I've come across this pump failure modeling. This is similar to what we have. This is similar to a problem that and this is how they have solved it. And don't forget to always mention the business value. Now, how is it going to help us? Okay, this is going to help us reduce our repair costs. This is going to help us reduce our production shutdown because of the maintenance, right? So when you take this approach, this is usually helpful. It's not guaranteed, but it's been a challenge, and I think it's always going to be a challenge.
Thank you. We had a question similar by Sheila. Okay. She said it's similar. So Robert Meyer, would you like to ask your question live, or should I read it out? I'll give you a second to unmute if you want.
Can you hear me all right?
Yes, we can.
Okay, great. I work in a rather similar space. So we are a startup in cement and concrete. So your journey feels quite similar. So I'm curious, like, how often do analytics and ML projects actually get stuck in pilot purgatory and never make it into production in oil and gas?
Well, oil and gas is still a little bit in the earliest stages of these, like the AI ML adoption, right? And there's been some of the organizations are actually really advanced. They have data science organization within their enterprises. They have community of practices. They have analytics kind of departments. And they have been identifying many of these use cases and added them to their portfolio as we see them in the predictive maintenance and the production optimization. But you're bringing a good point that some of these projects are stuck in the POC because it's sometimes I find that it's hard to justify the cost to develop that the POC and move from the POC kind of stage to the production. When it comes to the business value, it's hard to justify the cost of deployment. And that's when we need to be really careful and kind of when we are developing these solutions that it has to have the business value and has to have a quick time to value, and we have to prove the return of investment. And that's why most of these projects, they can move out of this POC because it's hard to scale and it's hard to justify the cost.
Maybe
Thanks.
We have 3 minutes left. Roxana, would you like to ask your question as well?
Yes, hi. Could you speak about how you approached limiting data movement and data automation? Because I assume you use a lot of sensors and they must store information in multiple sources and formats. So I'm curious about the limiting data aspect.
Okay, that's a really great question, Roxana. It's so in our platform, Digital Hub, we have actually implemented a single source of the truth on the platform. So in every project that you start in Digital Hub platform, once you have the data in the project, it will never have to move that environment. So you do all your analysis and development. If you want to do a machine learning or time series or what analysis that you want to do on your data, you will do it on the platform, and then it's accessible through let's say your BI and visualization application in the platform. So you don't have to move the data around. You don't have to push it to different data storages and shared folders just to be able to access it through your visualization that you want to share your outcomes, right? And that's what we want to limit the movement of the data and just be able to maintain the single source of the truth.
Thank you very much. Our time, unfortunately, is like on the spot. We have 1 minute to go. So thanks again very much, Hoda. And yeah, enjoy the rest of the conference.
Thanks, Florian. Thanks, everyone.